Two students to the homework cup video, page 371. Let's go ahead and get started right away. The directions simply say to simplify the expression, okay? Simplify the expression. So here we go. Notice here we're multiplying like bases. My base is 3. My base is 3, and I'm multiplying. You have learned in the past that when you're multiplying like bases, you write the like base once, and you add the exponents. 1/4 plus 3/4 is 4/4, or 4/4 is just 1, and 3 to the 1 power is 3. Number 11. Same thing. When you're multiplying like bases, your base is 1/3. Your base is 1/3. Multiplying. When you're multiplying like bases, write the like base once. Add the exponents. So 1/5 plus 3/5 is 4/5. Now, I want you guys to get used to checking to see if you can take this further. Now, that is the answer, by the way, okay? But pretend you didn't know that on a test or a quiz. The next thing you would do is go like this. You'd put 1/3 on the inside. You put a 5 here and a 4 here, okay? And then sometimes you can take this even further. Now, in this case, you can't. We do not know the 5th root of 1/3, and if you take 1/3 to the 4th power, you get 1 times 1 times 1 times 1 is 1, and 3 times 3 times 3 times 3 is 81. Well, we don't know the 5th root of 1 or 81, so this is as far as we can go, but always check and see and make sure that you can't take this a little further, okay? Very important you do that. We want to simplify these problems as far as they go. Alright, number 13, we've learned that when you raise a power to a power, you write the base and you multiply the powers. So 1/3 times 9/4 is 9/12. Of course, that reduces to 3/4. Now, that might be your answer. It might not be very quickly. Let's put 3/4 here. Put the bottom of the fraction here, top of the fraction here. We do not know the 4th root of 3/4. And if we take 3/4 to the 3rd power, we get 3 times 3 times 3, 4 times 4 times 4. We do not know the 4th root of these numbers. So this is as far as we can go. But again, always check, okay? Always check. Number 15. Okay, same thing again, students. We have a power being raised to a power, so we multiply those two powers together, okay? So your base is 6, not -6, so bring down your negative sign, okay? Then put your base, and then we have what? 4/3 times 3/7 would be 12/21, which reduces to 4/7. Now, I'm not going to take time and put this in a radical like I've been doing, but always check and see if you can take that further. In this case, we cannot, okay? Now, let's look at their answer. They have the 6 not in parentheses. Now, listen to me. Technically, they're right. My answer is correct, too. Here, what I'm saying is the base is 6 with a negative sign on the outside. They're saying the same thing, just because there's no parentheses like this. They're saying 6 is your base, and the negative sign is off to the side. Now, if their answer would have looked like this, then one of us is wrong, because these two expressions are not equal. Here, we have the negative inside the parentheses, so it's the entire base. Here it's on the outside, okay? So these two answers here are fine. I have no problem with either one of those, okay? But this here is not equal to this, and it's not equal to this, okay? Your base is 6. Your base is 6 right here. Your base is 6. If there's parentheses around it, then your base becomes -6. Number 17. Alright, now, 1296x, this whole thing to the 1/4 power. So in other words, we have this whole entire expression, 1296x to the 1/4 power. So this entire thing is to the 1 power. And my 4 goes right here. Now, let me go back for a second. When I looked at this problem, I saw there was nothing I could do. There's no like bases being multiplied. There's no like bases being divided. There's no simplifying or reducing I can do. There's really nothing I can do. So if I write it in radical form, maybe there's something I can do. Okay? So anything to the 1 power is just itself. So now I have this. Now, I do not know the 4th root of x. However, I do know the 4th root of 1296. With your calculator, type that in, and you will see that you get 6. 6 times 6 times 6 times 6 equals 1296. So, I do not know I do not know the 4th root of x, but I do know the 4th root of 1296. So cross that off and put a 6 on the outside, because the 4th root of 1296 is 6. And I'm left over with x on the inside. Now, understand me very, very, very carefully. You can only do what I just did if there's one term under the radical. And this is one term. They're multiplying, so they're one term. If there would have been a positive sign here, that's 2 terms. Or if there would have been a negative sign here, that's 2 terms. Then you could, if that was the case, if you had 2 terms, you could not take the 4th root of this and leave the x under the radical. That is completely unequivalent. But if you have one term, then you can definitely do that, okay? So we took the 4th root of 1296. It's 6, and here's what we're left over with: 6 4th root of x. Now, they took it a step further here. Here's why they did it. And I agree with this. I wasn't thinking. Quite often, if your original answer, if your original problem started off with fractional exponents or rational exponents, then your final answer should end that way too, to be honest with you. So we have 6 times the 4th root of x. So we have 6 times. Now my original problem started off with a rational exponent, so my answer is going to end with a rational exponent. Don't forget there's a 1 right there. So you write your x. The exponent goes to the top of the fraction. The index goes to the bottom of your fraction. And 6 times x to the 1/4 is 6x to the 1/4. And that is the answer, okay? Would I give you credit for this or in a test or a quiz? Maybe, but try to get to the habit of making your answer be written the same way your problem started off with. Number 19. Okay, we have 243y to the 1/5 power. Now, think about that for a second, okay? That entire term right here is to the 1/5 power. So I'm going to put the entire term under the radical. All of it to the 1 power, because there's a 1 right here with a 5 here. Of course, anything to the 1 power is just itself, so now I have the 5th root of 243y. Now I do not know the 5th root of y, but I do know the 5th root of 243. And you say, well, I don't know that. Well, that's what your calculator is for. Type into your calculator and see if it comes out to be a whole number, okay? The 5th root of 243 is 3. If you take 3 times 3 times 3 times 3 times 3, you'll get 243. So I'm going to cross this off. The 5th root of 243 is 3, and I'm left with the 5th root of y. Now that's a good answer, but your original problem had a fractional exponent, so your answer should too. So don't forget there's a 1 right here. So we really have 3 times y to the 1/5 power, 1/5. And of course 3 times y to the 1/5 power is just 3y to the 1/5 power. Okay, moving on to number 21. Okay, here we go. In the past you learned, whenever you're dividing like bases, and we are dividing like bases. Your base here is a 2, and your base here is a 2. Whenever you're dividing like bases, you write your like base in the numerator, and you take the top minus the bottom. So 1/5 minus 6/5, okay? 1 minus 6 is -5. So we have -5 over 5, okay? Now -5 over 5 is just -1, right? I mean, sure, 5 over 5 is 1. There's nothing left in the denominator, so we'll put a 1 here. Now, you do not want your final answer to have a negative exponent, okay? So pick up the exponent and its base, move it down to the bottom. So this 1 stays there. Times, now you brought this down, so it's right here. And now this -1 is positive. Nothing left up top, so put a 1. Now let's simplify that. 1 is up top. 2 to the 1 power is 2. Times 1 is 2. So there we go. All of this equals 1/2. Alright, moving on to number 23. Alright, now we're taking a fraction to the 3rd power. Okay? There's a couple ways to do this. You might want to reduce this first to make the number smaller. That's up to you. For example, real quick, off the top of my head, 2 goes into both of these. So 50 over 32. But I can reduce that again. 2 goes into both of those. So 25 over 16. Okay, so it looks like I should have used 4. 4 goes into both these. 4 goes into 125 times, and 4 goes into 64 16 times. Okay, now I cannot reduce that anymore, so now do you remember what to do? When you have a fraction like this being raised to this power, there's really a 1 right here, even though you can't see it, and a 1 right here. So 3 times 1 is 3. 3 times 1 is 3. And that's what we get, 25 to the 3rd power over 16 to the 3rd power. Now students, obviously feel free to use your calculator. 25 to the 3rd power is 15,625 over 16 to the 3rd power is 4,096. Now, 4,096 might go into this number evenly or it might not, but with your calculator, here's what you do. You type in 15,625 divided by 4,096. Okay? Now, when you do that, you're going to get a decimal. You're going to get 3.81469726. Now hit math, enter, enter, math, enter, enter, and you get the exact same fraction. So this fraction cannot be reduced. That is your answer. That's it. Okay? Allow your fractions, allow your calculator to do the work for you. It will reduce your fractions for you. Okay? Alright, moving on to number 25. Okay, same thing. We're dividing like bases. If you're dividing like bases, whenever you're dividing like bases, 9 and 9, you write the base once in the numerator. Nothing left in the bottom, so I'll put a 1 there. And you subtract 2/3 minus 1/6. 2/3 minus 1/6. Okay? Now 2/3 is the same thing as 4/6. So now they have a common denominator, okay? You should know how to do that. Now hopefully you guys remember, obviously, how to change 2/3 to 4/6, but real quick, in case you don't. A common denominator for 3 and 6 is 6. 3 goes to the 6 twice, times 2 is 4, okay? So 4/6 minus 1/6 is 3/6. Okay? Now, of course, 3/6 reduces to 1/2, so you really have 9 to the 1/2 power. Now, 9 to the 1/2 power over 1 is just 9 to the 1/2. Now, you would think you're done, but hold on, guys. We can take this further, and that's why I keep warning you guys to check. 9 to the 1/2 means 9 with a power of 1, the square root. Well, the square root of 9 is 3. So your final answer is 3. Okay? Make sure you're getting all of this. Number 27. Alright, here we go. 256x. Now, we do not know the fourth root of x, but we do know the fourth root of 256. I know that because I can type into my calculator and I will get out a 4. 4 times 4 times 4 times 4 is 256. So the fourth root of 256 is 4, and I'm left over with the fourth root of x. Now, let's go back a second to a problem like this one right here. Look at number 19, please. We wrote it as a radical, took the fifth root of 243 and got a 3. We did not leave the answer like this because the original problem was written with a rational exponent. So we wanted our answer to be written with a rational exponent or a fractional exponent, okay? In this problem here, our original problem is written with a radical. So after we do this, some of you might want to do this. You might want to put a 1 here and put x to the 1/4, then bring down your 4. 4 times x to the 1/4, and I understand why you would want to do that. But look at the original problem. Was the original problem written with a rational exponent, or was the original problem written with a radical? It was written with a radical, wasn't it? And so that means you want your final answer to be written as a radical. So that's your final answer right there. The fourth root of 256 is 4. We do not know the fourth root of x, so 4 times the fourth root of x. Number 29. Okay, same thing. Here we go. We have the fifth root of both of these numbers. Okay, now, if you would like to, sometimes you can reduce the fraction first. I'm going to quickly do that with my calculator. 7,776 divided by 243. Enter math, enter. Okay, you get 32. So 243 goes into 7,776 exactly 32 times. So now we have the fifth root of 32. And guys, 2 times 2 times 2 times 2 times 2 equals 32. Okay? So the fifth root of 32 is 2. That's it. Final answer. Alright, moving on to 31. Alright, now, this one's really not too difficult, students. I mean, look. I have a negative exponent. So I know I'm going to take the exponent and its base and move it up top. Okay? So there's already a 1 up top times 6 to the 1/2. I brought the 6 up top with its exponent and change the sign of the exponent. Nothing left in the bottom, so we'll put a 1 here. Okay, now 1 times anything is just itself, so 6 to the 1/2 times 1 is just 6 to the 1/2. All over what? All over 1. Anything over 1 is just itself. So there's my answer. Now, here's where I have a little discrepancy with the answer key. They're going to write it like this. Now, if you'll look, the original problem started off with a fractional exponent. So I personally would like your original problem started off with a fractional exponent. So I would like your original answer to start off with, or to end with a fractional exponent. But they did write their answer like this. Now, I understand that. I mean, put the 6 here. Top of the fraction goes here. Bottom of the fraction goes here. 6 to the 1/2 is the same thing as the square root of 6. Okay, I get that. But what I would like you to try to do is look at your original problem, see what form it was in, and leave your answer like that, okay? But again, this is fine also. Moving on. Alright, moving on to number 33. Now there's two different ways to do number 33, okay? Let me walk you through each way very carefully. First of all, you would be correct in saying this is one term right here. It's one term because they're multiplying. Now if there's a positive sign here, or if there's a negative sign here, then you would have two terms. But they are multiplying, so you do have one term. Because you have one term, you can definitely take your exponent and multiply it through times the other exponents. So we'll do it that way first. 2 times 1/4 is 2/4 you would get 1.1666666 repeating. Then hit math, enter, enter, and you'll get 7/6. Or you can do it the long way if you want. 1/2 plus 2/3. Common denominator is 6, so this becomes a 3. 6, this becomes a 4. And 3 plus 4 is 7. Either way, you get 7/6. Now, we have 4 to the 7/6 power. Okay, let's see if we can simplify that further. Put a 4 here, put a 7 here, put a 6 here. We do not know the 6th root of 4. Okay, and 4 to the 7th power is going to give me 16,384. We do not know the 6th root of 16,384, so this is as far as we can go, or this is as far as we can go. Now, your original problem was written with fractional exponents, so this is really the answer I would like right here, and that's what they have, okay? Number 35. Okay, now, let's really take our time and think this through for a second, okay? First of all, we have a cubed root over a cubed root, which really means the cubed root of this. Please don't forget that, okay? If they're both, if the top and the bottom both have the same index, you can write one big radical with the same index over all of this, okay? Now that kind of helps a little bit. Let me say this though. If you would have had a 4 here and a 3 here, then you could not do it. You would have to leave them two separate radicals. But notice both indexes are 3. So if both of your indexes are the same, you could write one big radical and put the entire fraction under it. Now 648 over 3 is actually a whole number. 216. Okay? So 648 divided by 3 is 216. Now, the cubed root of 216 is 6. 6 times 6 is 36. Times 6 is 216. So there we go. The cubed root of 216 is 6. Alright, moving on to number 37. Okay, now, let's think this through for a second, okay? We do not know the 4th root of 6. Well, first of all, notice we have one term right here. So we can take the 4th root of 6 or the 4th root of x to the 4th. We can do each part here individually. Well, first of all, I do not know the 4th root of 6. Okay? I do not. But the 4th root of x to the 4th, I definitely know that, okay? The 4th root of x to the 4th is just x. How do I know that? Well, let's find out. What's x times x times x times x? Isn't that x to the 4th? You have a 1 here, a 1 here, a 1 here, and a 1 here. Whenever you're multiplying like bases, you add the exponents. So x times x times x times x is x to the 4th. So when I ask you to find the 4th root of x, I'm saying what variable multiplied 4 times over, that's the same variable, equals x to the 4th. And the answer is x. X times x times x times x is x to the 4th. So the 4th root of x to the 4th is x. Put an x on the outside, and there's your answer. Now, a lot of you might want to put this, x times 6 to the 1/4, because there is a 1 right here. And that's okay, but again, your original problem had a radical. So I would like your original, I would like your final answer to have a radical. Okay, now, I know what the answer says. Let me explain this. They put an absolute value around the x. Now, let's go back up here and let's talk about this for a second. I would like you students for a second to pretend that x, forget this problem for a second, pretend x is -2, okay? If I put a -2 in for x, watch what happens. I'm going to raise it to the 4th power, okay? Which gives me a positive 16, okay? And then I'll take the 4th root of it. It'll be a positive number. I end up with this right here. Now watch. I put a -2 in for x, and I get out 6 times 16, because -2 to the 4th power is 16, okay? Now, from here on out, when I take the 4th root of this number, I'm going to get out a positive number. The 4th root of a positive number gives me out a positive number. million or any negative number, because first of all you're going to put into the problem. If you put in a positive or a negative number for x, it doesn't matter. It'll become positive because you're going to get to the fourth power. Then it's going to become positive because the fourth root of a positive number or of a positive number has to be positive. So that's why they put the absolute values right now on a test or a quiz. How picky would I be? I'd probably take off 1 point if you forgot to do that. Okay, probably 1 point. You have to see stuff like that and understand that. Okay, so this is the correct answer. So whenever you're dealing, now listen to me very carefully, and I'll kind of sum this up. Whenever you're taking a root of a number like this, the fourth root of 256, you have nothing to worry about. But when you start taking the nth root of variables, letters, always be careful and see if you need to put the absolute values. You can do that by saying to yourself, okay, no matter what I put in for x, would I get out a positive number? If the answer is yes, then you need to put absolute values around the x right here, or the variable. Alright, okay, number 39. Here's another one, okay? The fifth root of 32, x to the fifth. Now, first of all, let's start off with the 32. I do know the fifth root of 32, so cross it off. It's 2 on the outside. And I do know the fifth root of x to the fifth. Okay? Think about it, guys. The fifth root of x to the fifth. I'm going to write x times x times x times x times x would give me x to the fifth. So the fifth root of x to the fifth is x. So there's nothing left under the radical. There's no need to put a radical. Everything's gone. We pulled everything out. So there's nothing left. So your answer is 2x. But now here's the dilemma. Okay? Do we put absolute values or do we not? Well, I know what the answer key says, but you've got to learn to figure this out on your own. Okay? So let's see if you do. Alright? If you put a positive number in for x, like a positive 2, we know we'll get out a positive answer. That's obvious. Because a positive number raised to a power is positive, times a positive is positive, and the fifth root of a positive number is positive. But what if I put a negative number in for x? Would I get out a positive answer? Let's put a negative. Let's put a negative 2 here. Well, a negative 2 to the fifth power would be negative 32. Negative 2 to the fifth power is a negative 32. And 32 times negative 32 would be negative 1024. And the fifth root of a negative number is negative. So it looks like to me you're going to get out positive and negative numbers for x, depending on what you put in. Now remember, I just made 2 up. You could have used negative 1, negative 3, negative 4, negative 5, any number you want, okay? But when I put in a positive 2, I got out a positive answer. When I put in a negative 2, I got out a negative answer. So there's really no need. In fact, it would be incorrect to put absolute values around the x, because it looks like the x that you get out of the radical can be positive or negative, either one. So we do not need the absolute value symbols. Okay? Alright, moving on to number 41. Alright, here we go. Okay, we have the third root of 2x to the 6th. Okay, the third root of 2x to the 6th. So here we go. I do not know. First of all, this is one term, so I can definitely take the cubed root or the third root of each part of this term. I do not know the cube root of 2, so that's going to stay under the radical. I do know the cube root of 6, though. Remember what we learned. Whenever you're dealing with variables, you can take the exponent divided by the index. So x to the 6th, the cubed root of x to the 6th is x squared. I can prove that to you. X squared times x squared times x squared. Look at that. Equals what? X to the 6th, because you're multiplying like bases. So you write the base once, and what do you do to the exponents? You add them. 2 plus 2 plus 2 is 6. So x squared times x squared times x squared is x to the sixth. So the cube root of x to the sixth is x squared. So we're going to pull an x squared out here. Now it looks like we're finished, but the question now is, do I need absolute values? Well, this one can be answered, and I hope you understand this. This one can be answered very, very easily without doing a bunch of research on this problem. What is your x right here? It's squared, right? So I don't care if you put in a negative for x, or if you put a positive in for x, you're going to square it anyways. So it's going to come out positive no matter what. Now, if you want to do this, I would have no problem with that, but you don't have to, because it doesn't matter what you put in for x, it's already going to come out positive anyways, okay? So, you're welcome to put the absolute values in this problem, but you don't need to. And by the way, if you did it the way I showed you, where you go up here and put a number in for x, like negative 1, that's fine. If you put negative 1 in for x, negative 1 to the 6th power is a positive 1, and 2 times positive 1 is positive 2, and the cube root of a positive number is going to be positive. So it looks like it doesn't matter if you put a negative number in for x or a positive number in for x, you'll get out a positive number. Which makes you think that you had better put absolute values here, because the only thing you're going to get out here is a positive number. And again, if you put the absolute values because of that reasoning, that is totally fine. I don't mind that, but if you didn't, you're okay. You don't have to, because the x is squared, so no matter what x ended up being, you're going to square it anyways, which would give you a positive number. Not super easy to understand, but I hope that makes a little bit of sense, okay? Alright, guys, that's it for the homework help video. I hope this has been a help to you. If you have any questions, don't hesitate to call or email.